Okay, I'm back from grabbing the charts and we're ready to learn more about erosion. Now we're going to be talking about erosion by glaciers. So maybe you already know some things about glaciers. High up in the mountains in many places, it's cold even in the summertime. There are places on the planet where snow falls and it never melts because it's that cold. Every year, more and more snow and ice fall and they pile up. And so they pile up on each other and they make layers and layers of snow and ice. Huge amounts of snow and ice can build up, and eventually the weight of the snow and ice becomes so great that the ice begins to move. Now, it's really interesting to think that there might be so much ice and snow that snow moves, because we think of ice and snow as a solid, but we can actually get a river of ice and snow, and a river of ice and snow that flows down mountains very slowly is what we call a glacier. So a glacier is a slow moving river of ice. As the glacier moves, think about this because we've talked about water and what water does when rivers flow, and this is like a river of ice. We know that ice can erode, we know that rivers can erode, so think about this river of ice. As this glacier moves, it scrapes along the edges of the mountains and they erode the mountain edges and the bed where they're flowing. And when a glacier meets higher ground or a big obstacle, it can't flow around it like a river, because a river flows down and out and around, but a glacier is a solid. So all of that snow and ice, when it runs into something, it can't flow around it. It gets stuck. All of this snow and ice has a tremendous amount of weight that pushes and pushes and pushes down, and it pushes down the slope of the mountain. So glaciers only have a few choices. Sometimes a glacier can push a rock or obstacle in front of itself. So if it's something big, like a big boulder, it just ends up pushing the boulder out of the way. And that boulder gets broken up. But there's something else I'd like to tell you about glaciers. In colder parts of the Earth, particularly in the Arctic and the Antarctic, where glaciers flow all the way down to the sea, not just down valleys in the mountains, but flow all the way to the sea, just like a river, the glaciers encounter cliffs. So they get to the edge and there's nothing there except the ocean or the sea down below. What do you think happens when a river meets a cliff? It goes down. What's formed when a river comes on a cliff? A waterfall. Yes. When glaciers reach a cliff and the ice is solid, it flows out and out and out and hangs over the cliff until the weight is so great that overhanging ice breaks off and crashes down below. So it makes a huge booming, loud, echoing sound. I'll see if I can find a video to attach to your lesson. And it makes a huge sound, and then when it hits the water, it causes a big wave. And people say it sounds kind of like a roar, like the ice breaking up and falling in sounds like a roar. The glacier, the piece of the glacier that comes off the cliff and breaks off, becomes an iceberg. And an iceberg is a big chunk of ice that's broken off of the glacier. The process of glaciers breaking off and forming icebergs is called something funny. It's called calving. What? It's called calving. When glaciers break into pieces that become icebergs, it's called calving. It makes you think of a baby cow, doesn't it? As a calf, calving. Okay, the average moves about 2 to 3 centimeters per day. So 2 to 3 centimeters a day. Let me get my trusty ruler here. So it moves about that far, just over an inch every day. That's pretty slow compared to a river. Rivers flow very fast, but glaciers, rivers of ice, flow very slow. As the glacier travels, it erodes the land and ends up collecting a lot of debris, just like the water of rivers do. But instead of it being deposited on the bed, it's picked up into the ice of the glacier. Pieces of rock and other debris collect along the edges of this river. It collects it as it picks up and carries it. It's also grinding on the sides and collecting on the sides. the debris that collects along the edges of the river and pushed along are pushed along in front. These are called moraines. Moraines along the sides are called lateral moraines, and the moraine at the front of the glacier is called the terminal moraine. So laterals are on the sides and terminal is in the front. Sometimes two glaciers meet and become flowing down the mountain as one. So it starts off as like, can you make a glacier and another glacier, and they meet together and then they keep flowing down. And two glaciers meet and the moraines join up and end up becoming in the middle of the glacier. So sometimes you'll have them on the sides. So like if this is one glacier, you'll have moraines on the sides. And if you have two coming down, you'll end up having this one continuing. So you end up with a medial or a moraine in the middle, which is called a medial moraine. You can tell where glaciers have been because sometimes they melt and leave the moraines behind. And so you can see like evidence of where the glaciers have been. So I have a picture I want to show you about this that I colored. Let me switch into our view. Okay, so here's a picture I colored of a glacier in some mountains. You can see the Highland Mountains up here, and you can see here a glacier's coming down this way. Let me make it bigger. Okay, there we go. All right, so you can see that snow falls and falls and falls, and it's not melting away. And so this glacier's coming in this way, and this glacier's coming in from this way, and they're joining up. These over here, this is a lateral moraine, and this is a lateral moraine. This is the medial moraine that comes because these two glaciers came together. So we have a medial moraine. And this is the terminal moraine. It's the deposit left at the front edge of the glacier. Now, maybe you notice something happening up here. This is a little glacier up here in this little area, and it comes to like a cliff edge, and so its pieces can break off and land on the one below, but it's up higher. It's higher in the mountains, and it's been cut off by this big glacier that's coming down the mountain. So I just want to go through those parts again because it's easy to see them here. Lateral moraine is on the sides. These are the lateral moraines. Medial is the one in the middle, medial moraine. And the terminal moraine is at the toe of the glacier. We call it the toe of the glacier, the front edge of the glacier. So I want to show you another chart. I want to show you a chart of what it looks like once the glacier has receded back to the mountains, or in this case, the glacier has completely melted away. So you can see that the land looks very different. Now it's all green and lush. You can see that the lateral moraines are still visible. There's still rock debris that marks the edge of the glacier. And the terminal moraine, or the toe of the glacier, left this. That's all the further down it went. If it had gone further, then the terminal or toe moraine would be all the way off the map. You can see that where the medial moraine would be is now a river. That's the lowest part of our valley. And look here, do you remember that little tiny glacier that was up in the mountain? It eroded its valley, and when the ice melted away, and this ice melted away, now it's a waterfall coming out of there. This has a really special name. This is called a hanging valley. It's a valley that's been cut off, and so where the valley ends, it hangs above the other valley. And so this is the main valley, and this is a hanging valley. So let me see. I'm trying to remember what I haven't said. When glaciers move, they scratch or they dig grooves in the ground. And some places you can visit, you can see where glaciers have scraped or scratched or striated the rock surface. And I keep looking at Selena, but you can't see us. I keep looking at Selena because we've been to these places and I get really excited, and we're not the only tourists that do this, but when we go to places that have great glacial striations, I'm always like, look at the scratches on the rocks. And then I make the girls get out and look at the rocks, and I say, okay, which direction are the lines going? And we're like this. And then I say, which direction was the glacier going? And then they're like, it was moving that way. And I say, no, it wasn't moving downhill. The glacier was moving uphill. I don't know if that actually happened. But the first part where we looked at rocks with lines on them definitely happens. The last time we saw this was the last time we were at Mount Rainier, and we stopped off the side of the road and went on a little hike, and we could see the glacial striations where the rocks have been scratched. It leaves grooves and scratches in rocks. It's pretty cool. Some of the most, I'm going to just check my notes here. Some of the largest and most famous glacial grooves in the world are in Ohio on Kelly Island in the middle of Lake Erie. So that's pretty cool to think about. In Ohio, some of the best glacial striations in the whole world are there. So the Earth's climate hasn't been like it is today. So when we go outside and we look at what we see, that's not what the climate's been like through history. And so we can see evidence of glaciers in places that aren't cold right now and that haven't been cold for a very long time. But the rock record shows us what it looked like in the past. And so it's really cool that, just like we said in one of the great stories, that the pages of Earth's history are written in the rocks, and we can go out and see that. I have one more chart to share with you, and this one's fun because we've talked a lot about erosion by rivers, and when we go for hikes, I'm always like, what do you see? We see a stream. What kind of valley is it? It's a V. And we talk about rivers eroding V-shaped valleys. And some of you, this came up when you were following up rivers. We were talking about erosion of a U-shaped valley. I want to show you erosion of a U-shaped valley. U-shaped valleys are eroded by glaciers, not by rivers. Remember, rivers can carve V-shaped valley or a canyon, depending on how they're eroding. If they're eroding bank sand bed, or if they're eroding just the bed. A U-shaped valley is from ice. A U-shaped valley is only formed by moving glaciers, by that river of ice that makes a glacier. When glaciers melt, and move back up to the highlands, we call it the retreating. The glacier's retreating. It's moving away. And when glaciers retreat, they kind of like, they're not picking up anymore. They're really depositing still, because as they're moving backwards, it's melting. And so it's leaving behind the bits and pieces that it has ground up. And so when they retreat, or when they pull back, they carve this beautiful U-shaped valley. Glaciers are like bulldozers. They push the earth, they gouge it out, and they grind it up. And when they retreat, we get to see this beautiful U-shaped valley. A glacial valley or a U-shaped valley is what we see here. Now, when we were talking about the Hanging Valley, this isn't a great picture of it, but this is that idea. This is the U-shaped valley by that hanging glacier in the Hanging Valley, and how it is on the edge of a bigger one. So this is showing you that water, no matter what form, liquid or solid, carves, carries, and deposits sediment. And depending on what kind of water, liquid water or solid water, we can get V-shaped valleys or these beautiful U-shaped valleys. You can see that this is a U, like right up in here, you can tell it's a U. You can see this here. Yeah, U-shaped valleys are formed by rivers of ice, what we call glaciers. Thank you for joining us today for more erosion by ice and erosion by glaciers. I can't wait to see your follow-up. Have a great day.